Hello and welcome to the course of Learning Numerical Experiments using ANSYS Fluent. This is Mohammed Khan, your course instructor. By going through this course, you will enhance your knowledge and workability skills of dealing with a computational fluid dynamics solver such as ANSYS Fluent. You will learn to set up and solve complicated cases involved in CFD simulations. The knowledge gained through this course will help you tackle real-world engineering simulations. The course is divided into multiple number of projects which are simple yet complicated, which are application oriented and which gives you the right mindset for understanding the methodology required to solve a CFD simulation. The first project begins with the study of fluid flow in a domain. By going through this project, one will understand the procedure to assign or change the primary material in the domain for simulation purpose. One will understand the methodology required to set up the numerical scheme for solving these cases. And finally, we will analyze the results using the CFD post and understand the different techniques that are available for evaluating or representing the results. The next project focuses on understanding the discrete phase modeling technique in ANSYS Fluent. In this project, we will learn the procedure to set up a discrete phase model. We will learn what is injection. We will learn the process to inject a material in the domain. We will understand the procedure for evaluating or representing the particle tracks. We will see what are the different types of coupling options in discrete phase model. We will understand the Rosen-Rambler distribution. We will try to represent the particle distribution in the domain with the help of histograms. We will see what are the different boundary conditions in discrete phase model, for example, the trap boundary condition. We will go through the stochastic tracking technique, or also called as random walk model. Finally, we will be evaluating the erosion in a pipe, and we will learn the procedure to export the particle history into CFD post module for the purpose of visualizations. After this project, we will be moving to the next project that deals with the numerical simulation of flow field in the interior environment, also known as indoor ventilation. In this project, we will be validating the CFD code that is ANSYS Fluent with one of the experimental study. The project begins by understanding the experimental case. We will go through the inputs and outputs of the experimental study which is published in one of the journal. By going through the inputs, we will try to model a three-dimensional geometry using the Creo-parametric CAD software. We will dive into understanding the density-driven flows. We will understand what are density-driven flows and what is their significance and what are the procedures to be considered when we are solving a CFD case that involves density-driven flows. We will be deeply understanding the numerical scheme required for these kind of cases. We will understand what are the boundary conditions, and finally we will visualize the results and compare the results with the experimental data. The next project deals with the flow of hot gases from a car engine. This is a conceptual project. We will understand what is the project to be solved or what is the work to be done in this project. we will work on the three-dimensional modeling. We will understand how the model is created in the Creo Parametric software. We will import the geometry into Design Modeler and perform some design operations on it, which will help us to simplify the geometry. We will discretize the domain and set up the numerical scheme by adding different models, for example the mixture templates, by utilizing the species transport model. We will understand the different air properties which are required to solve these cases. We will understand and go through the different boundary conditions, for example the utilization of mass flow inlet. And finally, we will try to visualize these results in CFD post module. The next project deals with the combustion of fuel-air mixture in a cylindrical furnace. The fuel-air mixture used in this project is methane and air. We will try to model this domain in the design modeler. We will create a structured grid into the domain. We will see what is the numerical scheme required to be solved or required to be considered for solving these cases. We will add up the fuel air mixture, that is nothing but the methane air mixture, by utilizing the species model in the mathematical equation solved for this particular problem. We will verify the simulation and post-process it by utilizing the CFD post module in ANSYS. On the completion of the simulation, we will be utilizing the simulation for evaluating the nitrogen oxide formation post combustion. The next project will help you understand what is fluid structure interaction, that is nothing but the FSI analysis. So this is one of the conceptual projects in which we will be working on simulating the flow over a three-dimensional object. We will be performing a CFD analysis on it to evaluate the pressure acting on the body. We will utilize that pressure which is acting on the body to import it into the static structural module of ANSYS Workbench, and then evaluate the deformation, stresses and strains on the particular body. This represents us to understand the fluid and structure behavior on a body. Finally, the next project discusses the simulation of a rotating fan. This is yet again a conceptual project which will basically help you and guide you to deal with the process of solving these kind of cases. In this project, we will be beginning with a three-dimensional model in Creo Parametric. We will be building a domain for these kind of cases. We will learn to see the procedure for creating the domains when we have rotating entities involved in the project. We will be setting up a transient simulation for this project. We will be ensuring that we have achieved a proper convergence, and finally we will be visualizing our results in CFD post module of ANSYS Workbench. Coming to the prerequisites of the course, well, there aren't any prerequisites which are required from you. But you must have a computer to work along with the instructor. On the completion of this course, I ensure you that you will be having tremendous knowledge and exposure to a wide variety of applications that are involved in CFD simulations. I'm confident that your foundation will now be strong enough to tackle and work with any kind of CFD simulation in your career. I'm sure you can work in any research activities, you can work on publications, you can work on concepts, you can work on modifying the design systems and publish any paper in any journals. And finally, you will be able to take up academic and technical projects. So, what are you waiting for? Join now to enhance your expertise in computational fluid dynamics.